You know, every single day, from the moment you wake up, your brain is doing something incredible. It's constantly making sense of the world, connecting dots, drawing conclusions. But have you ever stopped to think about how you're thinking? Turns out we've all got this amazing set of logical tools we use, most of the time without even realizing it.
So let's just ask it directly. How does your brain actually do it? I mean, how does it take this absolute flood of information coming at you all day and turn it into a picture that makes sense? Well, it's not magic. It's actually a process, a set of logical operations that are, believe it or not, pretty systematic. The best way to think about this is like having a mental toolkit, right? For different kinds of jobs, like, say, proving a point, or spotting a pattern, or just making a really good educated guess, you pull out a different tool. And today, we're going to open up that toolkit and get a good look at the 3 most important tools you've got inside.
Let's just call these tools by what they do. There's the tool for certainty, the tool for spotting patterns, and the tool for making the best guesses. Now, in logic, they have fancier names: deduction, induction, and abduction. But these labels really get to the heart of it. So let's start with the most airtight, heavy-duty tool in the box: certainty.
This right here is deduction. When you use deductive reasoning, you're not messing around. You're aiming for absolute 100% guaranteed conclusions. There's no room for maybe. If your starting points are true, your conclusion is totally inescapable.
And that guarantee is everything. Deduction is what's called non-amplitive, which is just a fancy way of saying it doesn't actually add any new information to the world. It just reveals what was already hidden inside your starting points, your premises. That's why it's the logic of proof.
Ah, the classic Socrates example. And there's a good reason it's so famous. It shows this perfectly. Look, if we accept premise 1, that all men are mortal, and we accept premise 2, that Socrates is a man, well, the conclusion that Socrates is mortal isn't some brand new idea. It's a logical necessity. It has to be true. That's the raw power of deduction.
Okay, so let's move on to our second tool. This is where things get a little different. Unlike deduction, induction isn't about certainty at all. It's all about probability. It's the tool we use constantly when we see patterns and then make bigger generalizations based on what we've seen.
And here's the crucial difference. Induction is ampliative. It does add new information. It takes a few specific things we've seen and makes a leap, a projection about all the things we haven't seen. Now, this is incredibly useful for navigating the world, but it also comes with a big risk.
The famous swan problem shows this perfectly. Imagine you see a swan, and it's white. Then you see another, and another, and another. After seeing 100 white swans, you start to form a general rule. Okay, all swans are white. And it feels like a really strong conclusion, right? But it's not guaranteed. All it takes is for one single black swan to show up, and boom, your entire theory is toast.
The philosopher Bertrand Russell totally nailed this built-in danger of induction with this fantastic and kind of grim little story. From the chicken's point of view, the inductive evidence is overwhelming. Every single morning confirms the pattern. But as Russell points out, a pattern from the past is no guarantee of the future. This is what's known as the problem of induction.
Okay, and that brings us to our third and maybe my favorite, most creative tool in the toolkit: abduction. If deduction is the logic of a mathematician and induction is the logic of a scientist running experiments, then abduction is the logic of a detective. It's Sherlock Holmes's favorite tool.
Abductive reasoning basically works backwards. You start with some surprising fact or observation, and then you work your way back to generate the most plausible hypothesis that would explain it. It's not about proving something or predicting a pattern. It's about proposing a cause. It's an inference to the best explanation.
These examples make it crystal clear. You look outside and the streets are wet. Now, could a fire hydrant have burst? Yeah, I guess. Could a fleet of street cleaning trucks have just gone by? Maybe. But what's the simplest, most likely explanation? It probably rained. Same thing with a doctor. They see the symptoms, fever, cough, sore throat, and make an inference to the best explanation. You've got the flu.
So, let's just put the two you'll see most often head to head. On one hand, you've got deduction. It gives you guaranteed proof, but the catch is you don't learn anything new. On the other hand, induction gives you the incredible power of discovery and prediction, but you have to give up that guarantee of absolute truth.
And this table just pulls all 3 of our tools together beautifully. Just look at the goal for each one. Deduction wants to prove, induction wants to predict,
Abduction wants to propose. And check out the direction of the logic. Deduction goes from a general rule down to a specific case. Induction does the exact opposite, from specific cases up to a general rule. And abduction? It jumps from an observation to its most likely cause. Totally different tools for totally different jobs.
Look, if you only take one single thing away from this whole explainer, please let it be this. This is the entire toolkit in 6 simple words. Deduction proves. Induction predicts. Abduction proposes. It's simple, it's powerful, and it's super easy to remember.
So why does any of this matter right now? I mean, this is ancient logic stuff. Well, it matters because these very tools are at the absolute heart of one of the biggest, most important debates happening today, the true nature of artificial intelligence. You've probably heard this term, stochastic parrots. It's a critique that suggests AI models are really just incredibly sophisticated mimics. They've seen billions of examples and are just repeating the patterns. In our new language, this is an argument that they are absolute masters of inductive reasoning, spotting patterns and predicting what comes next, but that maybe something is missing.
So this is the central question, isn't it? Can these systems make that creative leap of abductive reasoning? Can they generate a genuinely new hypothesis to explain something they've seen? Can they truly make an inference to the best explanation, or is it just a clever remix of their training data? That, right there, is the line between just matching patterns and what we might call true creativity.
So, here's a challenge for you. The next time you read an article, or listen to someone make an argument, or even just try to figure out why your toast is burnt, think about the tools. Ask yourself, am I proving something? Am I predicting something? Or am I proposing an explanation? Once you start looking for them, you'll see these fundamental logics absolutely everywhere, shaping the very way you understand your world.